finishing some notes from 2.3. We ended on 2B, so we're going to get started on question 3. What is this, on the 3rd page? Question 3 says, Lainey calculates that the school has about $120 to spend on t-shirts. From which company will $120 buy the most t-shirts? So we're comparing No Shrink to Mighty T. And up above, where is our equation? Is that on our 2nd page? We created an equation for both of them. Yes, on our 2nd page. Problem 2.3, right at the beginning, we said that Mighty T's equation is C equals, I'm going to rewrite these just so we have them in front of us. C equals N plus 49. That's Mighty T. I'll put Mighty here. And Shrink, their equation that we created was C equals 4.5N. Now we have it in front of us. And now we can go on to answer this question. They want to know how many t-shirts, which is represented by N, we can sell if we have $120. So how would we go about calculating that? What's our C represent again? Angela, what does our C represent again? If we have a capital C over there, our total cost, and I just said our N represents the number of t-shirts. So Angela, how would I calculate this if they told me my cost, we spend $120? Where can I calculate that into Mighty T's equation? I'm sorry, can you say that again? If this is our cost, and this is our number of t-shirts, where is it appropriate to put our $120? Minus 49, yeah, technically you're missing the original equation, but yeah, that's basically what we're doing here. We would plug in 120 for our total. So our C would be replaced by 120, since that's what they told us. And that's going to equal N plus 49, because that's the equation that we have. So Angela, this is where you're saying we're going to subtract 49. We want to get N by itself, because we want to figure out the number of t-shirts that we're going to have. Well, we can't do that with our 49 here. Since they're adding N plus 49, we have to do the opposite and move it over and combine it with our other numbers, because we have a number here and we have a number here. We want to combine them. So we're going to subtract 49. That's going to cancel out. And subtract 49 over here. Well, 120 minus 49 gives us what? $120 minus 49 gives us, Lily, 71. And since that canceled out on the right-hand side, we have 71 equals N. So for Mighty T, $120 will give them 71 t-shirts. So now we have to figure out No Shrink. So we're going to do the same exact thing for No Shrink. But they have a different equation. They have C equals 4.5N. We want to get N by itself. And how are we going to calculate that for No Shrink? Eden, how would we set up the equation? Yeah, so what would I have on my left-hand side? What would I put in place of C? 120 equals 4.5 equals N. So they're multiplying 4.5 times N. We want to get N by itself, so we're going to do the opposite. I'll give you 1 minute with your shoulder partners to figure out the total for N for the Mighty Shrink. And it says for which company will buy the most t-shirts, which means you're going to compare your N for Mighty T, and you're going to compare your N once you find it for Shrink. Who has the most? That's all they're asking. So I'll give you 1 minute to talk about that with your shoulder partners. Okay, Eliana, how did you solve the rest of this problem? Yeah, you had to divide this since they were multiplying it. Good job. So what did you get when you divided that, Eliana? Yeah, 26.6 repeating. Basically, you can't have 0.6 of a t-shirt, but in this case, it would be like 26 to have a whole t-shirt because you can't round up. So, in their question, from which company will $120 buy the most t-shirts? Well, when they're both given $120, who will get the most? Blake? Mighty T will, exactly. Shrink has 26, and Mighty T has 71. So we can say Mighty T will have the most. Awesome. For A, for which number of t-shirts is the cost of the two companies equal? So we want to know when they're equal to one another. And what is that cost? Well, we know the two equations. Does anyone want to take a quick guess as to how we would set them equal to one another? How do you think we would do that? We want to find the number of t-shirts. We can find when they both have the same amount. If we take this equation, n plus 49, which is our mighty t's, and then we can simply set that equal to our other equation, which is 4.5n, right? The right-hand side is my shrink. What are they called? The shrink t's? No shrink t's. And on the left, it's mighty t's. I set them equal to one another. Now I can bring my numbers together and my variable n's together and solve for n. So here's a number, here's my other variable, and here's my other variable. Well, these are together. So let's bring my 4n and n's together. How would I go about doing that? What would I move? I have just my number over here, and then a 4.5n and an n over here. Here's my variable. So I can take, why don't I subtract it? Let's combine them together. Combining them together, this is positive n. I got to do the opposite and subtract it because I want to combine my n's together. When I do that, my n's cancel out, and on the left-hand side, I'm left with 49 equals. And when I take this 4.5 minus 1 whole n, 4.5 minus n gives me 3.5n. I'm just subtracting 1 n from it. Now that I got this, I'm a step closer to getting n by itself. What's that last step I have to take to get my numbers together? I have a 3.5 connected to an n over here. How am I going to get that away from that n? What should I do? We're multiplying. So I'm going to do the opposite of multiplying and divide it away from that n. 3.5 to both sides. What you do to one side, you have to do to the other. When I divide that, my n's cancel out. And then 49 divided by 3.5 will give me a grand total of n equals 14. What part are you confused on? Okay. Okay. So once we got those numbers completely by themselves and those variables completely by themselves, that gave us our n equals 14. So in B it says, how can this information be used to decide which plan to choose? How can this information be used? With your shoulder partners for about 1 minute, talk over how you think this information can be used to decide which plan to use. So based on what Lily was saying, for 4B, it says, how can this information be used to decide which plan to choose? We're going to look at 3 and 4A. In R3, when they told us the amount of money, $120, Mighty T's gave us a significant amount more of shirts. So we can get more shirts for that price, a lot more, than what No Shrink would give us. Because in Mighty T's, they would give us 71 shirts. For No Shrink, they would give us about 26 shirts, both for $120. So we can look at what they are when they're the same amount of money. And we can even check that by plugging in 71 for our n in the next equation. That's true, but we don't know that for sure. We're just making assumptions on that. So, we could say calculating, oops, the same amount for both equations will help to decide which company has the better deal. Because in three, we can get way more shirts for the price of 120 than no shrink can. So we're going to go off of that. What? Yeah, it would too. Okay, let's get going on 5A. It says explain why the relationship between the cost and the number of shirts for each company is linear. We should be up here. There shouldn't be any more conversations. They told us we know that this is linear. Explain why the relationships between the cost and the number of shirts for each company is linear. So we know it is linear because how can we determine that it is linear? Based on the equations we have. Robert? It goes up in a straight line. Yeah, we can. We haven't graphed it yet to exactly know that. Robert, what about my equations that we've had? Look at both of my equations. What's our slope-intercept equation? Slope-intercept. Y equals mx plus b. Every time we graph an equation that's in that form, we get a straight linear line. A linear line. So, we know that this is a linear because Mighty T's equation is basically y equals x plus 49. Right? X, or n in this case, plus 49. Well, our other one is 4.5n. That's like saying mx. That's my 4.5x, and it happens to have no b. So we know that these are linear because the equation is written in the form y equals mx plus b. And the rate of change for both of them are constant. We can write, oops. We could say the constant rate they have a constant rate of change. What is their constant rate of change for both of them? It's that m. What is their constant rate of change? What's it going to move up or down by? Mighty T's going to... Gavin?
I think it was...
What's our equation? What's our constant rate for Mighty T's? It's n plus 49 is our equation. So our constant rate is going to be before that n. The number before the n. In this case, they don't have a number, so we're going to assume that that's a 1, right? Mm-hmm. So Mighty T's constant rate is 1. And what is no shirts? They have a number before the n. What is their constant rate? 4.5. 4.5, exactly. So they both have a constant rate. They're not the same, but they both have one. So that's how we know that they're linear lines, based on just looking at those equations. It's in that form, and they both have a constant rate. In 5b, it says in each equation, what is the pattern of change between the two variables? In other words, how much does the cost change for every 1 unit that n increases? Every unit that n increases by 1. So this is what Gavin was saying. Our constant rate, 1, and 4.5 is 4.50, really. That's what they're saying, $4.50. That's our constant rate when it's going up by 1 unit. Our constant rate, just by looking at those equations, you look at your m, what your m is. Question? C, how is the situation similar to the previous two problems? So we're going to look back to our last two problems. Let's see where they are. Problem, let me find it. Oh, right back on the third page. Look back on your third page and look at your last two problems. How are they all similar? I'll give you 2 minutes with your shoulder partners to talk through this. Okay, so we're looking at those two equations that we've been working with. N plus 49 and our 4.5n. In these problems, how do we determine that they're linear? What's similar between them? We know they're linear relationships. All the problems are linear relationships. Between what? What does a linear relationship have? It has a constant rate of change? Yep. And what else does it have? We have a independent and a dependent variable. So if we have C equals 4.5n, one's depending on the other. One of those is depending on the other. Between the independent and dependent, these are our vocabulary words from 2.2 it was. And also, like you just stated, there is a CROC, constant rate of change, going on in both. We're going on to B. It says the following table represents the cost for another company. Now we're adding another one in there. Here's the table they created. They didn't give us an equation, but they gave us a table with their points. It's called the Big T. It says, for one, compare the cost for this company to the cost of the two companies in question A. So we're gonna look at this cost. What is our number of shirts going by in the table? What is the number of shirts going by? Rebecca. What's it going from? 0 to what? Our number of shirts, just our shirts. You guys, we shouldn't have these side conversations. Only Rebecca should be talking to me. I'm sorry, what'd you say? 3. We went from 0 to 3. So what about my cost? Brayden, what are we going from? 34 to 41.50. So what's the difference there? $7.5. And that's for 3 shirts. So how would I determine what one shirt costs? Ashley, if I know $7.50 is for 3 shirts, how would I find what one shirt is? I'm sorry, Ashley, everyone else is talking. What did you say? Yes. We would divide it by 3 to figure out what 1 is. So $7.50 divided by 3 gives me how much, Ashley? When we divide that, we get $2.50 for 1 shirt. So when we're looking at this, we can say that the cost per t-shirt for Big T is $2.50 for one shirt. And they also charge an initial fee of, how do we determine what their initial fee is? That's right off the bat before they sell any shirts. Yes, Zane. We look at where their 0 shirts are and how much do they charge at 0 shirts, Zane? Yes, exactly. So they charge an initial fee of 34. So that's the same thing as our other two equations. We could determine how much per t-shirt and if they had an initial fee. That's how they're similar to one another. It says, is this relationship linear? If so, what's the pattern of change? Is this a linear relationship? No, why is it not? Anthony Coleman.
It isn't because the numbers for n are going up unevenly. Like they're not going up at a constant rate.
Well, what is our constant rate for one shirt? Up one shirt, up one shirt. So is there a constant rate? Can we make that into our equation? It does have a constant rate. They're not exactly showing us it. This went up by 3. This goes up by 2. This goes up by 3. This goes up by 2. So there is a pattern going on. And if we were to do the same thing for the other side, we can determine what their constant rate is for one shirt. So if we can determine the constant rate, is it linear? Exactly. So this one is linear. Because it has a constant rate at $2.50. That's all you need, at least for a linear line, is a constant rate. It doesn't clearly show that in the table, but we can determine what the constant rate is per shirt. This gives us the constant rate, the difference of 3 shirts, and it goes 2 shirts, and it goes 3 shirts, then it goes 2 shirts. We can still determine that. We can calculate what 1 is and go up by 1s there. Yep, exactly. If we graph it, we can still determine that straight line. But to have a linear line, you do need that constant rate. So if we go on to 3a, it says, would the point 2, 84 lie on the graph? Well, let's create our equation for this. I'm going to create it at the bottom of our last page. We know to have a linear line, we want y equals mx plus b. That's the equation we have. Our b is our y-intercept, which is that initial price that Zane was telling us about. Zane, what did you say our initial was? 34. So I could plug that in for our b and have y equals something for my m. What would my m be? My m is my constant rate, which is also my slope. So Anthony, what did you say my slope was? 2.5, or I'll put 2.50. If I could write it in this equation, that also shows that I can plot it on a graph and put it in that equation and make a linear line. So since I have the equation, when I go on to 3a, I'm going to rewrite my equation up here now. Here's my equation that we just created. And those points, with the points 2, 80, or 20, 84. What's my 20? Is that x or y?
X.
What's my 84? Y. Whenever we have them in coordinates like this, they're always written as x, y. So whatever that first one is before the comma is always your x. So now since they gave us those points, we can determine whether they lie on the graph if we simply plug it in. So let's plug it into our equation. What's our y again? What did they tell us y is? 84 equals 2.5. What's my x? 20 plus 34. Okay, I can simplify this. 2.5 times 20 gives me 50 plus 34, and I still have 84 on the left. Well, now 50 plus 34 gives me 84, and on the left I still have 84. Well, does 84 equal 84? Yes. And because they equal each other, that point 20 comma 84 does lie on this graph. So we can stay over here on the left-hand side. Yes, it is a solution of the equation. So if they gave us points and we know our equation, we should always be able to determine whether that point that they gave us lies on that graph by plugging it into our equation like that. If we go on to B, it says, what information about the number of shirts in cost do the coordinates of 2 comma 84 represent? Well, what does the 2 and what does the 84 represent? Or I keep saying 2, I'm sorry, 20. Well, this is my equation. I'm going to write it up here, right here. Y equals 2.5x plus 34. If I recreate that, like stated in our table, because they gave us n and c, not x and y, this would really be my total cost equals 2.5, depending, is one shirt. So this would be 2.5n plus 34. So $2.50 is the price per shirt. Per shirt. That's why it's connected to my X. Per shirt. So instead of X, if I were to write N for number of shirts, if I say 2 shirts, I can plug that in for N and calculate what the total cost of the 2 shirts would be. Can't I? Does everyone see how you can calculate that total cost? So if I give you 2 shirts, Elena, where would you plug it into this equation on the left-hand side to find the total cost? Like we did with Henry, and what we did with, what was the other one's name? Emil. We had C equaling our total cost. And our constant rate has to go up by a certain price per shirt. Well, I can't put in a C next to my 2.5 because 2.5 per cost, that doesn't make sense. If I have 2.5 per the shirt, because they told us that 2.5, we calculated 2.5 is one shirt. That makes more sense. So what would the 20 and the 84 in that first equation represent? We have 20, comma, 84. And who was it? Robert, I think you told us that that was X and that was Y. Someone else said that? Lily, you said that?
No.
Oh, okay. Question? Just so we can determine which one of these is our number per shirt. So if we go back here and look at our table, N and C, well, this is our X, and this is our Y. So we can determine what to replace with N and C and what to replace with X and Y. So if we go back to our page, that's why we changed this N to an X and this C to a Y. So all we did is replace it with N and C because we're working with costs and number of shirts. X's and Y's kind of look a little fuzzy to us because we're not working with X's and Y's. We're working with costs and number of shirts, right? So in this question, if they were to say 20, what do those represent? Well, our 20 represents our X. And if we go back, let me move back a page. What does our X represent? X represents our N, which is a variable for what? Number of shirts, exactly. So the 20 is 20 is the amount of shirts bought. And the 84 then, which is our Y, would be our cost, right? We can put it into our slope-intercept form, y equals mx plus b. But the variables c and n are going to make more sense to us since we're working with the number of shirts and total cost. So down below that, it says write an equation. Well, we already wrote our equation. We've wrote it a couple times. C equals 2.5n plus 34. There's our equation for big T. And it's now asking us, is this a solution? So we can plug these in like we did up above and solve for it. Before they gave us 20 and 84. Now they're asking us new numbers. Is 20 and 80? Right? These are very similar numbers. They said 20 and 84. Now they're just asking us new coordinates. Is 20 and 80 going to be on our line? We need to figure that out. We're going to figure that out by taking our equation that we rewrote in C and plugging 20 and 80 in for it. When I plug those in, what should I get on the right-hand side? 2.5 times 20 gives me what? I'm sorry? Robert? Okay. Are you sure? Yep, 50. So 2.5 times 20 gives me 50 plus 34. My left-hand side still has 80. Now if I were to keep combining my 50 and 34, Lily, what happens? We did it looks very similar to 3A, but look at your coordinates. In 3A, they told us 20, 84. In D, they told us 20 and 80. So it's different numbers. They look very similar, but they're different numbers. So I have 80 on the left. Guys, we're not done yet. And 50 plus 34 gives me what? 84. Does 80 equal 84? No, it does not. So this is not, this is no. It is not a solution. And lastly, we would do the same thing with this last one, 14 and 69. I'll quickly do it for you guys. But we're plugging it in just like we did the last two. 69 would be where my y is, equals same exact equation. 2.5 times 14, because that's the numbers they gave us, plus 34. 69 is still on the left, and when I multiply 2.5 times 14 plus 34, that gives me 69. Does 69 equal 69? Yes. So we would say yes, the point 14, 69 is a solution. If one side equals the other, then it's a solution, and it's a point on that line. If they do not equal each other, then it is not a point. Here is our summaries that is connected to your page. And I will write your homework on the board. Homework is due tomorrow. The homework is page 42. Numbers 7 through 9. 42, numbers 7 through 9. And this is due tomorrow.